Good morning, fourth grade. Today's lesson begins in the Flint kitchen. So we're going to take a look today at measurement that happens frequently in a kitchen. And I have 3 measuring cups up on my counter here. I have kind of a small one, a medium, and a large one. And we're going to take a closer look at that. So in the kitchen, when you use measuring cups, you are measuring volume or capacity. And last week we talked about units of measure for volume and capacity, and I know this is really hard to see, but this says 2 quarts over here, and this side says 8 cups. 8 cups is equivalent to 2 quarts, and then there are smaller parts of those 2 units of measure on this side. This is the customary measurement side of my measuring cup. Now if I flip it over though to the other side, we have the metric side, and this one says 2 liters right here, which is equivalent to 2,000 milliliters. We'll talk more about that in a second. This is 2 liters though, so remember the other day I said 2 liters would be like a soda bottle that you might have in your fridge. So this is 2 liters. This is 1 liter. You can see there, which is 1,000 milliliters. And then this smaller one is 500 milliliters, which would be half of a liter. So let's take a look in the refrigerator and see what we see about measurement. So here we have a few items. So let's look at our milk. So the milk, the unit of measure here is at the bottom. This is a half of a gallon, which a gallon is a customary measurement unit. But below it you see a fraction or a decimal number, 1.89, which we say 1 and 89 hundredths. And then it says liter, capital L is for liter. So now we have, typically in the United States now, you're going to see the customary measurement and the metric equivalent. So here we have some pickles, and the pickles say 52 fluid ounces, which is customary. Then it says 1.625 quarts, which again is customary. And then the decimal equivalent is 1,538 milliliters. And then let's see what else we have. Pesto. Pesto, yummy stuff. 624 grams. So they actually put the metric measurement first, which is equivalent to 22 ounces. Now, we're not going to switch back and forth between measurement systems. We're only going to talk about one at a time, but you could do that if you wanted to. So I can also look in the cupboard here. Here's my peanut butter, and it says 48 ounces, which is customary, 3 pounds, because there are 16 ounces in 1 pound, so 16 times 3 would be 48. That's how you get 3 pounds. And then the metric equivalent is 1 36 hundredths of a kilogram. So we'll talk about what that means also today. Same thing with soup. Where does it say? Here it is. You can see 10 1/2 ounces, which is customary, and then 298 grams. So yesterday we talked about length, and length is one form of measurement. The other 2 forms of measurement that we're talking about are weight and capacity. Now weight, you know, in the customary system uses pounds, ounces, and tons. In the metric system, we tend to refer to it as mass. And the unit of measure that we are working with in mass is a gram, and it goes by a lowercase g. And then we use prefixes in front of that to talk about how many grams. From a volume standpoint, in capacity and volume, we talked about capacity being cups, ounces, fluid ounces, gallons, those kinds of measurements under the customary system. In the metric system, the basic unit of measure is a liter, and we refer to it by a capital L. And then we use the prefixes in front of that L to talk about how many liters. So the basic unit of measure for weight or mass under the metric system is the gram, and a paperclip weighs about 1 gram. So the relationship that we want to know today is that if you had 1,000 grams, that would be equal to 1 kilogram. And the prefix here is kilo, K-I-L-O, and it means 1,000. So 1,000 grams is equal to 1 kilogram. We just use a K to indicate kilo. So another conversion we are interested in today is milligrams. Milligrams is indicated with an M in front of grams, and it takes 1,000 milligrams to equal 1 gram. So just imagine if this were 1,000 milligrams, a milligram is a very, very tiny unit of measure. So if we're talking about capacity, we're talking about liters, and that is a capital L. And if you remember from the kitchen, this was my liter container, and it was sort of the middle of the 3 sizes that I had. And it said here that 1,000 milliliters is equal to 1 liter. So just like with grams, milliliter is equal to 1 liter. 1,000 milliliters is 1 liter. We could also say that 1 liter is, oh no, excuse me, that is not correct. We could say 1,000 liters is equal to 1 kiloliter. So the prefixes work the same way. We just change the basic unit of measure depending on what we are measuring. So if you could open your book, please, to page 497, you can see that there are a couple of these measurement conversions that we need to know. That under the metric system, a unit of mass, 1 kilogram is 1,000 grams, and under for liquid volume or liquid capacity, 1 liter is 1,000 milliliters. Okay, so if we were to compare kilograms to grams, it says Becky planted a flower garden full of blueberries. She used 9 kilograms of soil. How many grams is that? Well, 9 kilograms times 1,000, because it takes 1,000 grams to make a kilogram, would give us 9,000 grams. So she used 9,000 grams to plant her bluebonnets. We could do the same thing now with liters and milliliters. Becky used 5 liters of water to water her bluebonnet garden. How many milliliters of water is that? Well, if it's 5 liters, and we know there's 1,000 milliliters in a liter, we would multiply them to get 5,000. It would take her 5,000 milliliters. So let's look at this gray box here. Are kilograms heavier or lighter than grams? Well, keep in mind, it takes 1,000 grams to make a kilogram, so that means it must be heavier. Will the number of grams be greater than or less than the number of kilograms? So if you think about it this way, a gram is very small, a kilogram is very large. So obviously it's going to take more of the smaller unit to fit the larger unit. So it will be greater. And so what operation did we use? We used multiplication. Let's move on now to page 498. And we'll go through this together and keep learning. There are 3 liters of water in a pitcher. How many milliliters are in the water? Well, a liter is the basic unit of measure, okay? A liter is this container. But it wants to know how many, let's say we have 3 of these, but we want to know how many milliliters there are. Remember, there are 1,000 milliliters in 1 liter. So we would do 1,000, well, we know there are 1,000 milliliters in a liter, and since I'm changing from a larger unit to a smaller unit, milliliters is the larger unit, milliliters is a very tiny unit, you can multiply 3 by 1,000 to get 3,000 milliliters. Okay, so we're going to do that every time we go from a larger unit to a smaller unit. You're going to use multiplication. So 4 liters turned into milliliters. We know there's 1,000 milliliters in 1 liter, so there would be 4,000 in 4 liters. Now, what happens if we start with kilograms and change them into grams? Which of these is the larger unit? Well, kilograms are very large. Grams are very small. So we are now going to multiply 6 times 1,000 to get 6,000 grams, because it takes a lot more grams to make 1 kilogram. 8 kilograms changed into grams. Again, we use multiplication. And the same thing going from liters to milliliters. We're starting with the larger unit, going down to the smaller unit. That means we're going to use multiplication. Okay, and you can do the same thing here. If you could fill out these two tables, pause the video, fill them out, and then come back and check. Well, hopefully you saw there was a very clear-cut pattern happening here, right? Pretty simple if you think about going from a larger unit of measure to a smaller unit of measure, then you're going to use multiplication. All right, so I would like you to work on page 499 on your own and then come back and check with the key that I have attached. All right, good luck.